hope everybody enjoyed their ice cream. It was all right. So, I saw this talk the first time at PuppetConf Boston. This is Pascal Hahn. He's going to talk about multi-tenant Puppet systems and all this side of like organizational change. It was really cool to listen to. So, I'm not going to spend a lot of time. Here's Pascal. He's going to talk.
Awesome. Thanks.
Oh, I do have one side note. If you have questions at the end, please either use that microphone or I will toss you a handheld so that we can get them on the recording.
Right. So, as he just said, my name is Pascal. I'm managing a team called 4 in Nokia. It was a project where a bunch of system engineers that got slightly annoyed with what their job was like started writing something hopefully better and utilized Puppet for a lot of the stuff we did. I'm with Nokia for about a year and a half. I started as an engineer, and for some reason they thought I might be okay in management. I was a reliability engineer in Google before, also working on automation, but not with Puppet in this case. A lot of people ask me when I talk here, is Nokia not just doing cell phones, and what the hell are you doing with Puppet? Actually, we're not just doing cell phones. Major business that we're having is about mapping and maps in general. So Navtech is a company that is part of Nokia. We do maps in rather big websites. So Yahoo and Bing, for example, are using Nokia maps in the backend. So that requires 2 or 3 servers, and they want to be administered in some way. So what we currently do with Puppet is really a multitude of things. We deploy a very wide range of services. So there's everything from giant old school enterprise databases to new Node.js setups to processing pipelines to Hadoop to, I don't know. It's a multi-purpose platform intentionally. Teams always find new ways and fun areas that they use the platform for. We're working with all environments that Nokia offers. So it's basically the developer, the first day he does any development, he probably is going to get in touch with us. He's going to get a couple of boxes in some lab that are managed by the tool called Thor. And if he ever decides he wants to take it to production or testing or whatever, he basically can just use the same tool to deploy his service in all environments. There's minimal amount of change. We have a config engine that is like a pretty big ENC that is override based. So we provide you with variables that you might need, like here's a send mail server, here's a log server, this is how this data center is configured. You can override it for all the environments, he can override it for his application. It's a pretty open system, written by some of the Puppet Labs guys actually like a year and a half ago. I think Dan Bodie wrote the initial system, and we broke it from there. There's a strict versioning and isolation in the system, so it's basically like a regular software development approach to how you do Puppet. So you write your code on trunk, you eventually make a tag, and from there on the code is not changeable anymore. You can run production against trunk, which we do not suggest. You should run production against the tag and make yourself and us happy. It's basically deployment as code and lots of automated testing that we add. So if you commit anything, it's going to go through a series of tests. We're going to make sure that your Puppet code is at least semi-sane, that the syntax is correct, that the catalog compiles. You can do tests against the catalog, that the catalog actually does what you think it should do. We have a bunch of small custom functions, like encryption of passwords, for example, where you can store passwords in the configuration through an ENC in an encrypted way, and the Puppet master is going to know how to actually extract it so we don't expose any confidential data to people that, well, should not see that data. We recently added a RESTful API to manage Yum repositories, so all the stuff we deploy is RPMs. So we have a small API where you can basically manage your own repo. You can upload RPMs, you can delete them. They automatically get distributed globally and are visible in all data centers instantly. We added last week an API to actually change the configuration that we have for the ENC. So developers can basically do push-button rollouts by just hooking into this RESTful API and trigger their production configs, staging configs, whatever they want to do. So this is about what we do at the moment, but the process to actually get there was a slightly different one. When I started, we deployed system, or even before I started, we deployed systems in various mysterious legacy ways. So there was several bash scripts on somebody's laptop. They were basically the things that every system administrator is going to have a horror from when he even hears about it. So somebody started rolling out some Puppet system with like a giant IPP and a rather manual process, and the idea was like, oh yeah, we do these two environments. There's development, there's production, you don't need more. Eventually, we actually needed more because the stuff broke all the time. So you had search applications ending up on map renderers, or big databases on a map renderer, or other ways around. Basically, the system was not quite doing what we wanted, and so a bunch of thinking happened. And we have some very senior engineers, especially Oliver, who's got a lot of experience in Puppet. He helped us tremendously there and wrote most of this system, and came up with a system called Thor, which is basically what I described earlier there. We launched the first customer in June 2011 in one data center, pretty tiny deployment. And from there on, it grew. And it actually grew a lot more than we anticipated. We went from one customer in June 11 to 120 customers at this point. So this is a whole lot of teams all around the world. I gave this talk in June, and I changed the slides today. We had 90 customers in June. We have 120 now. So it's the growth rate is beyond what any of us was expecting. I should have put one number here. The engineering team actually grew by 2 engineers. So not quite the same ratio that we had in customer growth. So customers are in all time zones. We have West Coast, East Coast, Finland. There's folks in India. They're all over the place at this stage. My team's all in Berlin, so the support is also making it even more fun. The machine fleet literally exploded. We're in all data centers around the world at this point, or the major data centers that Nokia runs around the world. I didn't even calculate a percentage anymore, but it's thousands of hosts at this point, and we started out with a tiny, tiny fleet. We also went from the underdog solution that was basically just written for a system engineer team that was very angry and annoyed to actually being the de facto standard if you want to deploy anything. So this is probably not a big surprise, but we hit 2 or 3 problems along the way. Some more on the technical side. Puppet scaled pretty good and to a point where the Puppet master really started hating on us pretty bad. It was about 300 or 400 machines where the Puppet master was basically running at a constant load of about 15 on a 4-core machine. So we had to do something there. So the simplest solution we could come up with was we have one master Puppet master that basically does all the SSL fun and signing certificates and all that. And it just uses Apache's load balancing modules to balance to a whole pool of Puppet masters in the backend that will do all the expensive stuff like catalog compiles, no store configs. In our case, I was talking to some folks earlier. And at the moment, we're going with 3 slave puppet masters and 1 primary, and that scales very well, to say the least. You do cert signing only on the master, otherwise there can be some fun issues with this, and we just sync the certificates automatically between the slaves and the master, so we can do a re-elect if the master dies. A re-election takes, I think, 3 or 4 minutes. It's just flipping a DNS record. We did not automate it, because so far we actually did not have a whole lot of reliability issues with this. One other thing in a very different way was the way you lay out your data center is actually going to be fundamental on how you want to scale. So scaling a Puppet master to an infinite amount of machines, or scaling a compute unit in a data center, is very hard. And it's a pattern that is hard to fulfill, especially when it comes to big organizations where you want to have fixed units that are basically easily orderable. Like if I need a new data center, I don't want to go through a process that is easily 9 months in some big corporations. I just want to go there and say, I need another unit and put it here. So what we're doing is the idea of a cell that basically is completely independent. Like in this case, it's 8 times 16 hypervisors, the physical machines, which equals out to roughly 1,000 VMs in our case. It's a standardized hardware. We run the same hardware everywhere as far as we can get the same hardware again. The network setup is standardized, so the networking team knows exactly what they have to do when we tell them, it's like, please give us another data center of Thor. It's a repeatable and testable setup. So we actually have a set of tests. It's like a regular unit test idea that we wrote, where the data center operations team is giving us a definition of a data center when they hand it over. So giant CSV file that just says like, these are your OAs, these are your ILOs, these are storage heads that you should see, these are switches, basically a whole specification of a data center. We use that as an input to a unit test. So when they actually say this is the data center, I want to make sure that it really is that data center. So we run these tests, and basically if all lights turn green, I can be pretty sure that I can turn up a data center in a minimal amount of time, and that I know which unit or setup I'm actually working with. One thing that really became obvious once we went to so many customers is that even tiny manual steps that you got to do are going to hurt yourself really bad. We used to have a pretty big build pipeline where it's 2 Jenkins jobs for every release of every customer's modules. So your trunk basically has a syntax check and it has a compile time check. The output of those jobs is an RPM that contains your Puppet recipes. This RPM gets distributed to Puppet masters, and that's essentially how Puppet masters version their environments. So customer X environment Y equals an environment on the Puppet master that automatically gets deployed through RPMs that we built in these Jenkins jobs. Since we focused on other things at the beginning, you had to, when you created a tag, manually create those Jenkins jobs. It was a small thing because usually it was like maybe a tag a day across all the customers that got created. Once you're at 120 customers, it's likely that you have like 10 to 20 of these a day. When you have that many, you also add a lot of customers, so it quickly became a pain and ate up like an engineer basically for like 2 or 3 hours a day. The other problem is it's error prone. Everything you do manually, you gotta make mistakes, customers are gonna get angry, they're gonna shout at me, and I don't like to be shouted at. So I was like, okay, so let's automate this. So we want to do it in a repeatable way. So the build pipeline itself actually should be able to build itself. If I blow away the build pipeline, or if I decide I want to move it to a different data center, I should not have to do any clicking. So one of our engineers automated the Jenkins setup we have completely end-to-end when it comes to Puppet. So this goes to the point that he brings up Jenkins servers, he adds jobs through Puppet. He brings up the slaves know how to communicate to the master. It's a complete Jenkins setup that does all the stuff we need. It brings up slaves with different operating systems and like the whole shebang, basically. So the one end on the Jenkins server is actually we got to know what do we actually have to build. So what you see here is just the output of the job generating job. It basically looks into the repository. It's like, which customers do we actually have? Which tags do we have? And it'll create every single Jenkins job for all those and make sure that they're configured the right way, that they run when the customer commits code. When the customer creates a new tag, this thing runs every 3 minutes, so the Jenkins server will pick it up and we'll just add the jobs that are required. Once these run and they're successful, the RPMs get pushed, so this is also how we essentially manage our Puppet masters, or the fleet of Puppet masters in all the data centers. This is the result. There's a bunch of Puppet jobs, Puppet build jobs, where, so you can see a lot of customers have several tags and there's trunk, and they run quite a bunch, and in this case they all succeed, which is not common. And the very other end is basically, this is on a Puppet master that we're running, where we wrote a small script that basically knows exactly which RPMs it should install, and we just hook straight into the Yum APIs and deploy the RPMs that should be there on the Puppet masters. In this case, it saw that there's a new tag created, so it actually installs it on the master. The biggest problem we face is like, it's great to have a lot of customers, but a lot of customers cause a lot of problems. And we still had the same amount of engineers, and we actually wanted to keep on developing the system and not just do support. Because no engineer really likes to give support. It's at least none that I met so far. Luckily, most customers actually had pretty similar issues and complaints. Probably the biggest complaint that I got, it's going to be 2 slides, but this is everybody was saying, like, oh, I can just do this by hand. This is a lot faster. And integration takes so much time. So we were thinking pretty hard. It's like, okay, it's a it's a fair point, and what can we do? So we basically give people the basic integration for free. So Nokia has a monitoring system. There's like Graphite, there's Nagios, there's Splunk, and like bunch of products. And basically, if you bring up any host and you don't do anything to it, it's going to be Nagios and the appropriate Nagios for your environment. So the development server speaks to the development Nagios, production to production. Your machine will export metrics from collectd to Graphite, so you can actually alert against metrics as well, and people know what their machines are actually doing. And we export default logs to Splunk. So the security team wanted to know, it's like, hey, there's these authentication logs. We'd like to have them in a centralized place so we see if people do stuff that really shouldn't be there, if any box gets rooted, or I don't know what. So in order to actually make this really useful for customers, you need a way for them to extend the integration. So get them started with something, but make it very easy for them to extend it. In this case, I only have 2 examples. So the upper one is if a customer decides that he wants to add a Nagios alert. He just adds the recipe, or to his recipe where he actually deploys the service. This Nagios service is a define that we built. And this is basically just going to make sure that this alert appears on the Nagios server, this recipe gets instantiated. We made this as easy as we can. I think everybody, or probably most of the people here, used Nagios before. This looks pretty straightforward. The nodes URL is one thing that we enforce, and we break the build if people don't. This is, Nokia's running in a tiered support setup, so you have like a team in Bangalore that is tier 1 and 2, and then you have the tier 3 system engineer teams, T4 R&D. When the guy in Bangalore gets an alert on this thing blows up, do something, it would be nice if if we would tell him what to do. This is what we enforce here with the wiki. I think we actually at this point break the build if you put google.com in there, because some people did before. But yeah, this is the description of what the alert is, what is actually broken, how do I fix it. And below, it's how do I get a custom data point into collectd. If your application is exporting some counters and you want to export that in the context of the machine, you can just use this, and it's going to get exported. We have the same thing for Splunk. We can just say, these set of log files, I actually want to export them to this index. I want to do this and that. It's just a pattern that we try to follow with all the shared services that we're running. This is probably the biggest complaint I get a lot. Puppet is hard. Bash is so much easier. I don't quite agree. So we try to make it really easy for them to get going. So when you request an empty project that basically doesn't do anything, you bring up the machine and it's going to show you this beautiful baby. It gives the people a recipe that does something and that shows them how to do Puppet. This is fairly well documented. It's a dead simple Puppet recipe, but just changing the perception of people on actually getting something working and then going from there, instead of giving them an empty project and wish them good luck and give them a book. This has been working a whole lot better. We also started building standard building blocks. So Nokia basically has a bunch of groups of applications, but I think the majority of applications that is run is usually Tomcats with some Java applications or a little bit of Apache. And that's pretty much 80% of the applications. So building standard blocks for them and actually providing them a module that sets these services up in a same way. Make them parameterized in a way that they can actually change it and they make it work for their application, but give them standard settings where they don't shoot themselves in the foot. It does not just make the team happy, but it actually makes the security folks happy because they see if customers are doing stupid shit or not. The bigger challenge I had was how do I actually scale my development team? It's very hard to find Puppet talent, and especially if you have a lot of system programming going on in Puppet and not just on Puppet itself. The skill set is quite rare on the market. So we found that it's actually a lot easier to hire a smart system engineer that is a generalist or a very good software engineer that has some background in systems. If you try to explain system behavior to a software engineer, they usually have an easier time than a system administrator to pick up low-level coding. Yeah. we got more lucky with front-end guys. A lot of the Ruby people that actually applied for the jobs like, oh yeah, I've used Rails before. Isn't this the same? It's pretty hard to teach somebody that did Rails how to do system programming, at least from what we saw. One bigger problem that we had as well, we had very good developers in the team, but every developer kind of had their thing. It's like, oh, he's the virtualization guy, and he's the Puppet guy, and this guy's the system guy, and this guy's the testing guy, and that's all cool, because you can get stuff done very quick. If one of those guys is sick or decides to leave the company, you're in trouble. Some other engineer has to pick it up. If you only work with single developers in a single area, you won't have a lot of feedback on quality of the code, on the approach. It's always going to be the same approach that one person takes. So we ran through quite a lot of pain to actually get the team to a point where everybody could work on every piece of the code base. That includes the virtualization automation that we have, utilizing mcollective to manage hypervisors, to all the Puppet code with the ENC, the configuration system, then all the Splunk stuff took a while for people to pick up, and I think it slowed us down for about 3 to 6 months when it comes to development. The payoff has been huge, because you add people to the team and they learn all the areas, which takes longer, but your throughput in the long term is great. Because you can actually take the whole team and focus it on one topic as well, which is something that you usually couldn't do. So if you need to fix a big bug in one of the backend systems, you can just say, well, every developer works on this for 2 days, we've got to get this out of the way, and it'll work. Support was eating up a lot of time of the development team. We don't have a dedicated support team for this product. And a lot of the users, they come from an R&D background, but they never really worked with deployment systems or anything that is close to the system itself. So there was a lot of education involved where myself and some engineers traveled a whole lot to give trainings on how do you actually do deployment. Like, what do you have to look out for? What do you really not want to do? How do you use Puppet? We saw a lot of very horrifying Puppet code in our time. I'm still interested on the PuppetDB just to see how many exec resources which customer is using. It was very entertaining, but also very scary to see that people actually run their production code with very low quality Puppet modules. So we had to do a lot of education there, which it basically paid off once we started doing a lot of documentation. None of the engineer really likes to write a lot of user-facing documentation on how to actually use Puppet and document best behaviors, give more examples, work with people directly to help them fix their code, look at code even if people don't ask you, and make some suggestions on how they can make it easier on themselves. But the payoff in the long term was huge because people finally started helping other people. Like, this is the users helps users, helped reduce the load on the development team drastically. We gave some incentives to people to get there, but it's been helping. IRC is great. If you just get a developer to hop onto IRC, you can shout at him, which is good, so it is good for your temper. And they tend to take the time to actually write down what their problem is a lot better, which is great. The on-site face-to-face trainings have been really helpful as well, where we'll go to one of the locations and do like a 1 or 2 day sitting down and actually deploying a demo application with a larger group where you get a lot of people in one place, and maybe half of them actually understand the system afterwards. So they start teaching others, and they hopefully start teaching others, and so you only have to go back in about 6 months to teach some new folks. The next steps in the whole system is all around basically refining what we have at the moment. I think we got a pretty good system. When it comes to managing Puppet masters, we were first looking for open source projects and couldn't really find anything that tackled this problem with like the testing approach that we wanted to have. So we invested a lot of time in cleanups and in documenting the way that we actually work, and I hope I'll be able to release the management part that I described with Jenkins and Puppet masters and all that within the next 3 months. We want to revisit the testing methodology we use, and that's something where I actually got to talk to somebody in Puppet Labs. How many of you actually wrote Puppet tests so far? These test manifests? A couple. So we're having this fun issue that we release a library or a set of manifests for like Apache and for Nagios and all this. And you basically build your module against that. So your module path will include some stuff that we release, and you can just reuse the modules, which is pretty simple. Now, if you actually write a manifest that uses some of the modules we have, like the Nagios client, for example, indirectly, in your test you have to specify that, oh yeah, this class has to be present in your test because you depend on it, and otherwise your test blows up. Well, this is all good if you have one level of indirection where you say you use something and it's in a direct manifest. Now, if this is 3 levels deep, as a developer, I don't care what happens more than 1 level away from me. So writing these tests became increasingly harder the more complicated the Puppet setup got. So we're throwing a lot of thoughts back and forward at the moment how we can actually refine this testing methodology. If we can, instead of actually pulling in a manifest of a direct dependency, what about actually pulling in its test? Because that again will have the next direct dependency, and that again will have the next direct dependency. So in theory, we should end up with a working tree. The testing system is definitely not made for that, but we'll see. I actually want to see who in Puppet Labs works on this stuff. There has to be someday. We also got into the issue that we initially built the system for one system engineering team that would administer a bunch of applications, and that became a problem once it was actually 120 teams that are administering applications. Because everybody's got access everywhere, which is great, until people start breaking things, or somebody slightly misunderstands how Git actually works and does a merge that blows away the changes from the last 3 days. It's not so nice. So we basically need a permission model around configuration nodes. So if you say, this configuration should propagate through the ENC into my application, and we got to make sure that you actually have permission to that application that you're working with. So with the Git repo, which is our backend at the moment, it's impossible. So we wrapped APIs around it. We're about to change out the underlying storage infrastructure with the data store that then also introduces like a role-based permission model where I can say that you have access to these applications or you have access to this data center, and you won't be able to blow anybody else's changes away anymore. AWS support was a bigger topic that we worked on recently. So far we only supported internal data centers. So Nokia runs a bunch of data centers and you can deploy your stuff there. But Nokia heavily invests in AWS recently, so we're like, okay, we don't want to run different deployment code, and we kind of have all this Puppet stuff, so how do we make it work? So the setup we run at the moment is that we actually on-premise run Puppet masters and repository managers, which is it exposes Yum repositories. It's the API that we wrote essentially. And the workflow is when a host comes up in Amazon, it'll talk to Nokia, and that's the only thing he knows about. It's like, let's talk to this Puppet master. It'll get the certificate request. We have some code inside of the Nokia data center that then hooks into the Amazon API, figures out if it's a legitimate host. Is this a Nokia host? If it is, we sign the certificate, and the certificate works for the repository at the same time. So the host basically can, from then on, talk to the Nokia servers. If we want to unauthorize the host, we can just blow away the certificate, and the host can't get in anymore. Which is great, because it makes the same recipes work. We just treat Amazon as a different data center, and all the different Amazon data centers are different cells, and it seems to work so far. It needs to be wrapped up and be made shiny and all that, but well, if you'd be, on the very last note, if you're bored or looking for a fun job, or you like Berlin, because it's awesome, get in touch on DevOpsNokia.com or send myself an email. We're looking for engineers in pretty much every area. Very interested in front-end engineers at the moment, because we want to do a little bit more there. So if you know Rails, right, that's it for me, actually. Very short talk. Any questions, anything? Things that don't make sense? Or you shout.
You mentioned that you have a Yum REST APIs that you developed. Is that open source or not?
Not yet.
Not yet. Okay. Or do you plan to?
I'm sorry, I know, I promised it last time when I spoke in June, and we actually did not manage to open source it yet. We added a hell of a lot of features to it, though. Sorry.
And a quick question. You mentioned there is a problem with the Git repo. Something is impossible. I couldn't get that. Could you just elaborate on that?
You can't really give user permissions in a Git repo. You can't say this user is allowed to touch this stuff and this user is allowed to touch that stuff. It doesn't work. Or you can work with submodules, but it's a giant pain, so nobody really wants to do it. Otherwise, you get a merge back and forward, and it's not a whole lot of fun. So it just makes it more likely that people blow away changes, which is already a problem like that. And yes, we're trying to open source that RESTful API as well. It's just that we're currently focusing on the management of the Jenkins server, which actually includes the RESTful API as the very last step. So if the RPM is successful, we ingest it through that API into the system, which then distributes it to all the data centers. All right. Thanks.